Hi, Honors Algebra 2 students. We're in Chapter 5, Day 3 of Notes, and what we're going to focus on in this lesson is graphs of quadratic functions. We're going to be using vertex form to graph the quadratic functions, and then we're also going to graph y-intercepts and a symmetry point associated with that. And I want to emphasize that as you're doing the assignments that are associated with each day of notes, please make sure that you graph in the format that we teach you in the notes that day. In other words, we're going to teach you a lot of different forms to graph a quadratic equation in, and we want you to practice the different methods associated with how we teach them in the notes for that given day and then the corresponding assignments. So keep track of that as you're doing your assignment so that you get practice in each of the methods that we're showing you. And if you have a question about what method you're supposed to be using, make sure that you ask your teacher. All right, so let's get started. Just a reminder what vertex form of a quadratic equation looks like. It's going to be y minus k is equal to a times the quantity x minus h squared. And the vertex that results from that as we pull it out of the equation is h comma k. Those are the coordinates of the vertex. And in the prior lesson, we actually had you start practicing taking an equation that was in standard form for a quadratic and transforming that to vertex form. So what we're going to be doing today is transforming the equations from standard form to vertex form by completing the square. So we're going to be practicing that process that you learned in the prior lesson. But then in addition to that, we're going to state the vertex, find a y-intercept and a symmetry point, and use all of that to then graph the quadratic function. All right, let's get started. All right, so the first thing we're going to do to complete the square is that we're going to add 11 to both sides of the equation. So we get y plus 11 is equal to negative x squared minus 6x. And then as we learned yesterday, or in the prior lesson, you need to make sure that you have a positive 1 leading coefficient for your quadratic term. So if you don't have that, you need to factor out whatever is necessary. So in this case, I'm going to factor out a negative 1. I'll put a negative 1 for emphasis, but just the negative. And then I need to adjust my remaining terms. So that'll leave me with a positive 1x squared and then plus 6x. So in other words, just a reminder, I need a positive 1 right here before I move on to the next step of completing the square. And then whatever I end up factoring out, in this case I factored out a negative 1, I need to adjust the coefficient for the linear term here to make sure that these lines are always equivalent to each other as I go through the process. All right, now the next thing I'm going to do is I'm going to take this b value right here, or that linear value, and I'm going to divide that by 2. So in other words, it's going to be, 6 divided by 2, and then I'm going to square that. And obviously when I divide 6 by 2, I get 3, and when I square that, I get 9. So what I need to do then is I need to add that, in this case, to the right-hand side of the equation. And whatever I do on the right-hand side of the equation, I have to balance that out on the left-hand side of the equation. So I did add a positive 9 right here, but with this negative 1 being factored out, I added the equivalent of a negative 9. So on the right-hand side of the equation, I added a negative 9. So on the left-hand side of the equation, I also have to add a negative 9, or in other words, minus 9. All right, now let's go through and rewrite some things and clean some things up. So on the left-hand side, I'll have y plus 2. On the right-hand side, I should now be able to write this quadratic trinomial as a binomial squared. And so if I do that, that's going to become x plus 3 quantity squared. And I always tell my students, if at this point you cannot write this quadratic trinomial as a binomial squared, then you did something wrong in the process. All right, so we are now done with completing the square and transforming this equation from standard form to vertex form. Now I'm being asked to state the vertex. So the vertex is going to be negative 3 comma negative 2. All right, now what I'll do next is I'll put that -3, -2 in my table of values over here. Sometimes I put a little v beside it to note that it's the vertex. All right, now I reposition things a little bit so I can focus now on the graph. So I've got my vertex that I found from completing the square and changing from standard form to vertex form, and I wrote it in my table values here. I also rewrote my quadratic function here just so I have it for reference and can zoom in just a little bit as we go through and find the other values. Now we were asked to find the y-intercept. So the y-intercept, if I plug in 0 for x, I'm going to get a -11 for my y value. And then I should be able to find a symmetry point with respect to the y-intercept. So knowing that my vertex is at -3 or has an x value of -3, that means my symmetry point would be, if going from my y-intercept to my vertex is a distance of 3 units, I can go 3 units on the other side of that vertex and get that my symmetry point then would be -6, -11. And again, that's a symmetry point between the y-intercept that we found and were asked to find, and then a symmetry point with respect to that. Now, when I graph quadratics, I usually ask my students to graph 5 points. I think we have more precision and that type of thing. So why don't we pick some values in between, you know, here. And so for instance, if I pick a -1 and I plug it in, and sometimes I'll remind students, you know, you need to be able to do this without a calculator. So y would be equal to negative, and then I've got a -1 squared for my x value, -6 times a -1 minus 11. You know, sometimes you're going to have to write some things down because you should be doing this without a calculator. So that will give me a -1 squared will be a +1, but then I have out front here, I have the opposite of it. So in the end, that's going to be -1 plus 6 minus 11. So that's going to give me a -6. All right, and then if I plug in a -5, I would find that that would also yield a y value of -6. So you can choose these values wisely over here, so to speak, and then notice this is even a symmetry point between the -1 and -1 comma -6 and the -5, -6. Those are symmetry points as well. All right, so let's go through and do the graphing now. It looks like I'm going to need to scale my y-axis by 2s, so I'm just going to put, you know, a little 2 here on the y-axis, and I'll leave the x-axis scaled by 1s. That'll be fine. So I've got 0, -11, and again, I'm going to go down by 2s. So 2, 4, 6, 8, 10, 0, -11 will be right here. -1, -6 would be right here. -3, -2 would be right here. -5, -6 would be right here. And then finally, -6, -11 would be right here. All right, and then if we draw our parabola through that, and I should have made note at the beginning, sometimes it's nice to check and see which way your parabola is going to be opening so that you know you're in the ballpark, so to speak. So if we take a look at our quadratic equation, the leading coefficient is negative, which means we should have a parabola pointing down when we graph it. And also I want to remind you, around the vertex, make sure you make this as curved as you can. Don't make it look like a V, all right? I tell my students we're not graphing absolute value equations, which have a V at the vertex. We're graphing quadratic equations, so it should be more rounded around the vertex. All right, our next example, y equals 4x squared plus 12x minus 11. Once again, we're going to go through and transform this to vertex form by completing the square. So I will be adding 11 to both sides of the equation. That's going to be my first step. Then I'm going to factor out the quadratic coefficient. So by that, I mean I'm going to factor out a 4. Because I need a 1x squared left. So when I factor out a 4, I'll have an x squared plus 3x. All right, the next step I'm going to do is I'm going to take that linear coefficient, so that value of 3, and I'm going to divide it by 2, and I'm going to square it. And whatever value I get, I am going to be adding to, in this case, the right-hand side of the equation. So when I square that, I get 9/4. So I'm going to be adding 9/4 to the right-hand side of the equation. Now, what I end up adding to the left-hand side of the equation needs to be the equivalent of what I added to the right-hand side of the equation. So on the right-hand side of the equation, I know I added 9/4 right here, but 9/4 times 4 is actually 9. So that's what I'm going to add to the left-hand side of the equation. To the right-hand side of the equation, I added the equivalent of 9, so that's what I need to add to the left-hand side of the equation. All right, so if I simplify now, I've got y plus 20 on the left-hand side of the equation. And then on the right-hand side of the equation, I should be able to write this quadratic trinomial as a binomial squared. Now, on the one above, it may have been very easy to see what that quadratic trinomial was when I rewrote it as a binomial squared. It may or may not be easy to see on this one. So I like to direct you back to the following. Whatever this value was right here before you squared it, that is what is going to go down here as your second term in your binomial. So in other words, I took 3/2 and I squared it to get the 9/4. Well, that 3/2 is what's going to end up going right here. Be careful to watch the signs, you know, that type of thing, because they should carry down. But sure enough, if you take x plus 3/2 and you square it, you will indeed get this quadratic trinomial that you see up above. And again, some of them may be more obvious than others, but I like to give you that little hint on that particular one. Okay, now if we state the vertex, then we've now transformed from standard form for the quadratic equation to vertex form. If we state the vertex, our vertex will be equal to negative 3/2. Yes, we can have a fraction for that. It is what it is, comma negative 20. And then I'll go over here in just a moment when we continue with our graphing and write that in our table of values. All right, I should note when I originally wrote this, I wrote negative 3/20, so make sure you adjust that. So negative 3/2, comma negative 20. Okay, so we've been asked to find the y-intercept. So if we plug a 0 in for x right here, we're going to get 0, negative 11. We need to identify a symmetry point. So let's do a symmetry point with respect to this y-intercept. So if we look at this, you know, the vertex is going to be in the middle, so to speak. So going from negative 3/2 to 0 is going, you know, 1.5 units to the right, so to speak, if we think about it on a number line. All right, going 1.5 units to the right. So if we go 1.5 units to the left of negative 3/2, we'll have the x coordinate for our symmetry point. So 1.5 units to the left of negative 3/2 is going to be negative 3. And then that's a symmetry point with respect to the y-intercept. So our y value for that would be negative 11 also. All right, and then if we do pick some other values for x to plug into the original function, and actually I should say, you can plug these into the original function or you can plug them into the vertex form of that particular function since we rewrote it. Whatever works out better in your opinion when we plug these values in. But let's pick another couple of x values. So let's say we pick negative 1 for x and we plug it in either to the original function, that format, or the vertex form of that. We're actually going to get that the value is negative 19. And again, you may need to go through and actually write that out. So let's say we take, you know, the original form. Negative 1 squared is going to be a positive 1, so that becomes 4, and then minus 12 minus 11, it looks like, so that's going to be a negative 19. And then if I pick, you know, an x value of -2 and I plug that in, I would also get -19. All right, so let's take those 5 values now and graph those in our grid to the right. Once again, I'm going to scale my x-axis by 1s and my y-axis by 2s. So in other words, I've got, you know, I'll put a little 2 here or a -2 here since it looks like I'm going to be graphing all negative y values. So I've got 0, -11, which will be right here, and then -1, 19, which will be right here, -1.5, -20, right here, -2, -19, right here, and -3, -11 right here. So I've got a really narrow parabola. I could have scaled my x-axis, I guess, by something other than 1s to spread this out just a little bit more, but those are my points nonetheless with the scaling that I chose. Make sure that everything fits on your grid, okay? Don't add extra grid lines. Just do your scaling so that everything will fit. The original function had a leading coefficient that was positive, so we should be getting a parabola that's opening up, which indeed we are. All right, and there's what our graph will look like. All right, so just one more reminder before we go on to the last example. When you're doing your homework or the assignment associated with day 3, make sure that you are graphing from vertex form. So you'll have to transform the equations that are originally given to you from standard form to vertex form. And then you'll be stating the vertex. Once you've done that, you'll be identifying the y-intercept and a symmetry point. And again, those will give you 3 points to graph the parabola, but it certainly would not hurt to graph an extra couple of points so that you have 5 points for your parabola. All right, now the last example that we're going to do is actually on page 181 in your textbook, and it's problem number 33. So if that's listed on your assignment sheet, I'm going to do that with you in the notes. You do not need to repeat it on the assignment. And what we do with this particular example is a nice lead into what we're going to be doing in the next lesson. So the instructions say that we are to transform the general equation to vertex form. So we're given y equals ax squared plus bx plus c. And then in part B, we're going to write a formula for h, which represents the x coordinate of the vertex. So we're given, again, a quadratic function in standard form, and we're asked to change it to vertex form. And so I always tell my students this is a great, great opportunity to see how well you know the process of completing the square. Because notice that this is the abstract version of standard form. So, you know, instead of having like a 2 in here for A or a 5 in here for B and a, you know, whatever value for C, we are given that standard form equation very, very, very abstractly. We're going to go through, though, all the steps of completing the square to transform that from standard form to vertex form. Okay, so let's take a look at what that looks like. All right, so the first thing that we do is we're going to take the constant and we're going to subtract it from both sides. So we get y minus c is equal to ax squared plus bx. All right, the next step in the process is to factor out the quadratic coefficient. So I'm going to factor out the a. That leaves me with a positive 1x squared, which I always like to emphasize. And then we need to take this linear coefficient and we need to adjust it, in other words, for the fact that we factored out an a. So we're going to take this b value and divide it by a, and that becomes our new linear coefficient, you know, for x. And if you're ever not sure, okay, what should this be? Let's check it out. A times b divided by a is going to be equal to b. So at any point along the way in our work, all these lines of work should be mathematically equivalent to the line above it. All right, the next step in the process for completing the square is to take this linear coefficient, which happens to be b divided by a. We divide that by 2, and then we square it. All right, well, if we take b divided by a, and we divide it by 2. And another way of thinking about dividing by 2 is multiplying by the reciprocal. So instead of dividing by 2, multiplying by 1/2. And then we're going to take that and we're going to square it. So in the numerator, we're going to have b squared. And in the denominator, we're going to square the 2 and get 4. We're going to square the a and get a squared. So in other words, we've got, after we take this linear coefficient, divide it by 2 and square it, we get b squared divided by 4a squared. I also wrote right here that, this part right here is the equivalent. If we simplify it before we square it, the numerator is b, the denominator is 2 times a. Sure enough, when we square that, we get what I have written over here. All right, now we're going to take that value and we're going to add it inside our parentheses here, so to speak. What I add to the right-hand side of the equation, though, I have to take the equivalent of what I've added to the right-hand side of the equation, and I need to add it to the left-hand side of the equation. So keep in mind, I added this b squared times 4a squared to the right-hand side, but remember I've got this a out here. So the equivalent of what I added is if I take a and I multiply it by this b squared divided by 4a squared. Keep in mind, I've got an a in the numerator here and I've got an a squared in the denominator here. One of those ends up canceling out. So the equivalent of that is b squared all over 4 times a, because an a to the first in the numerator divided by a squared, and the denominator becomes an a to the first in the denominator. So this b squared divided by 4a is what I'm going to add to the left-hand side of the equation, because that's the equivalent of what I added to the right-hand side of the equation. All right, now if I take a look at what I have just added to the left-hand side of the equation right here, and I focus on just this part right here that I have highlighted in yellow, I'm going to take that part right there, and here's the thing. All of this represents a constant, okay? C is, in an equation that we are originally given up here where we have an a value, a b value, and a c value. That c value is going to be some value, so to speak. That b value is going to be a constant. That a value is going to be constant. In other words, all of that is going to be something that we could simplify. So what I'm going to do is between all of this right here, I'm going to factor out a negative sign. And if I do that, in parentheses, here's what I'll have left. I'll have a c value. And then if I factor out a negative, if I take a positive and I divide it by a negative, I'm going to end up with a negative and then the b squared all over 4a. All right, and then on the right-hand side, I've got my coefficient of a, and then I need to be able to take this quadratic trinomial and write it as a binomial squared. Well, if we go back to what we just talked about in the prior example, if you're not sure what it should be, let's review that. If we take whatever this value was, that's simplified before we squared it. So again, this value right here represents all of this before we squared it. It's just that it's simplified. So b divided by 2a was what the value was before we squared it. That's what represents the second term of the binomial. And again, we're going to bring the appropriate sign down. So in this case, it was a positive up here. It's going to be a positive down here. Okay, so believe it or not, we are finally done. We have transformed this general equation up here to vertex form. Again, very abstract equation, very abstract version of the vertex form, but we've done it nonetheless. All right, and I always say if you're able to do that, you have a very, very, very good handle on completing the square. The other thing is, and I should have said this up front, I'm sure you need to pause the video at different points in time and get all of that work down. And it wouldn't be a bad idea once you get all of the work written down to go back and listen to the explanation again if you were not able to follow it the first time. It's a great advantage of having the video. You can pause it and replay it. All right, and then part B said write a formula for h, which represents the x-coordinate of the vertex. So if you think about it, if this is in vertex form, you know, this represents h, this represents my k value. So we always take the opposite of what we see in here. So h would be equal to the opposite of b over 2 times a. And that may sound familiar to you because it does represent the x-coordinate of the vertex when we graph from standard form. So in standard form, if you're asked to find the x-coordinate of the vertex, that does indeed represent the opposite of b over 2 times a. And so we want to go through and show you where that comes from. In other words, this is the proof of where that x-coordinate for the vertex comes from, the opposite of b over 2 times a when we're graphing from standard form. So that's one reason we do it. Another reason we do it is it's a good practice for transforming from standard form to vertex form. And then finally, on the next lesson, you're actually going to be graphing quadratics from standard form, and this gives you a little appreciation for where that x-coordinate for the vertex comes from. All right, so this is the end of the Day 3 notes.